Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand IPv4 addressing. We will understand what is IPv4 addressing, like what is the classification of IPv4 addressing, how many classes are there, what are the range of classes, right? Everything from the beginning. See, IPv4 addressing is very important for ccna exam perspective, for the interview perspective, or even you are a network engineer, you want to learn any other technology. IPv4 addressing is important everywhere, right? First of all, you have to understand each and everything about IPv4 addressing. So in this video, I will try to cover all the important points about IPv4 addressing. So guys, without wasting our time, let's begin. First of all, what is IPv4 addressing? So guys, as you know, whenever we need to connect a device like computers, laptops, server, and endpoints, any devices, if you want to connect a device to internet, your device need two types of address. Your device need two types of addresses. One is MAC address, that is the physical address, and computer means, you know, an IC port have already one MAC address. If your computer in a machine have multiple NIC port, that means machine have multiple MAC addresses. And the second address that machine need to communicate our internet is IP address, right? So it is a type of address. Through this address we identify the devices. We can say we identify the devices on network. Okay, now what is the length of IPv4 address? What is the size of it? So guys, size of IPv4 address is 32 bits. It is an 32 bits address, and this is the first point about IPv4 addressing. It is an 32 bits address. If size of IPv4 address is 32 bits, that means total number of IP address is 2 to the power 32. Means total number of IP addresses which we have is 2 to the power 32. You know, it's around 4 million. Fine. Now next thing about IPv4 address is it is 32 bits address, and we have 4 field. Means we divide the entire address into 4 parts, into 4 field. Let's say, see, this is 32 bits address, means we have 32 bits, like it can be 00010, anything, right? 32 times 32 bits, and we divide the entire 32 bits address into 4 part. So if you divide 32 by 4, you will get 8. Means each field will carry how many bits? 8 bits, right? Each field will carry 8 bits information. Okay, so here next point about IPv4 address is we have or we represent IPv4 address into 4 fields, you can say, right? 4 fields. So we have 4 fields in IPv4 address, and each field carry 8 bits information. We can say each field carry 8 bits information, right? Means, because 8 why 8 bits information, because total length of IPv4 addressing is 32. We divide it into 4 parts, so each field will carry 8 bits information. Now by using 8 bits, what decimal value we can represent? Like if all 8 bits are 0, let's say 8 times 0, 4, 5, 6, 7, 8. If all bits are 0, that means we will get minimum value, and minimum value can be 0 in decimal if all bits is 0. And what can be the maximum value? Maximum value is if all bits are 1. If all 4, 5, 6, 7, 8, if all fields are 1, then we will get maximum value. And maximum value, if you will convert this binary into decimal, you will get 255 here, 255. So in one field value can be vary from 0 to 255, right? Value can be vary from 0 to 255 in each field. That means, let's say I have one IPv4 address, let me represent. And one more thing about it, that is we separate each fields with dot. We separate each field with dot. Now my minimum or my lowest IP address can be 0.0.0.0. It means all 32 bits is 0. Means in first field all bits are 0. In second field all bits are 0. In third field all bits are 0. And in fourth field all bits are 0. And the maximum value, if all bits in first octet is 1, then you will get value 255. 255 in field, in third octet, in third field, and in fourth field. We have 8 bits in one field, so we called one field called octet, one octet. So this is like first octet, this is second octet, this is third octet, this is fourth octet. We can say like this also, right? So in first octet, if all bits are 0, that means decimal value is 0. In second octet also, if all bits are 0, decimal value is 0. In third octet all bits are 0, decimal value is 0. In fourth octet all bits are 0, decimal value is 0. In first octet all bits are 1, maximum value is 255, decimal value is 255. In second octet all bits are 1, right? So value is 255. In third octet all bits are 1, value is 255. And in fourth octet all bits are 1, value is 255. That means if I will write this IP address into binary, so here if I will talk about the binary of this IP address will be 000045678 dot 000045678 dot 0000000 dot 0000000, like this. This is my there is no any difference between this and this address, both are same, right? This is in decimal, this is in binary, right? So if all bits in IPv4 address is 0 are 0, that means my IPv4 address is 0.0.0.0. And if I will convert this IP address into binary, so here value is all 1, here value is all 1. Here in first octet all bits are 1. 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, right? This is the maximum largest IPv4 address. So my lowest IPv4 address is 0.0.0. My largest IPv4 address is 255.255.255.255. All IPv4 address will lie between these two value, and this is the binary representation of lowest IP address, and this is the binary representation of largest IPv4 address. Now next thing is, see here I am writing one IP address, let's say 10.10.10.10. This is a valid IP address, and this IP address lie between this range. This IP address is in the range of these two value, minimum to maximum. Okay, so this is the one IP address. Like this IP address can be 192.168.1.1, IP address can be 172.16.1.1, right? Anything in this range, right? That is a valid IP address. Okay, so these all addresses are a valid IPv4 address. Okay, now hope till here everything is clear to you. Now let me move. Okay, so till now we understand the total length of IPv4 address is 32 bits. We represent IPv4 address into 4 fields. We differentiate or separate each field with dot. Each field will carry 8 bits information. Because of that, what can be my lowest IP address and what can be my largest IP address. Okay, now next thing is we divide the IPv4 address into some classes. You know why? Why we divide IPv4 address into classes? To reduce the shortage of IPv4 address, because see, we have only 2 to the power 32 IP addresses, and if you will talk about the population or devices, so devices is much more than IPv4 addresses, like, right? So we have lots of devices, we need lots of IPv4 addresses, but we have very less number of IPv4 address. That's why we divide IPv4 address into classes, into some class, like class A. First class is class A, then we have second class, that is class B, then class C, and then class D, and then class E. We have 5 classes. We divide IPv4 address into 5 classes. Now, how to identify the IP addresses belongs to which classes, right? Guys, for this, as I told you, that one IP address can be from 0.0.0.0 to 255.255.255.255. Now, understand very carefully. We divide IPv4 address. We divide IPv4 address with the help of value present in first octet, means value present in first field. What is the value over here in this field? According to that, we divide IPv4 address into classes. Like for class A, we define one range, that if value in first octet, means in first field, is from this range 0 to 127, so that IP address belongs to class A. If value in first octet belongs to this range, that means that IP address belongs to class A. In the same way, for class B also, we define one range of IP addresses in the first field only, right? In the first octet only, in the first field only, right? Not in the second or fourth field. In the second field or third field, value can be anything. If value belongs to this range 128 to 191, that IP address belongs to class B. This is the range for class B. In the same way, for class C also, we define one range, that is 192 to 224, that if IP address belongs to this range, means value in the first octet of IP address belongs to this range, that IP address belongs to class C. In the same way, for class D also, for class D, if value, here it is not okay, let me check the range once again. Range of IPv4 address, like this is range of private and public, range of class C IP address. So here range is 192 to 223. Here value is, as I told you, here value is incorrect. This is 223. If value in the first octet belongs to this range 1224 to 239, that IP address belongs to class D. And if the IP address belongs to this range, means 242 to 255, means that IP address belongs to class E. As a network engineer, you will work on these 3 classes, class A, class B, class C, not on class D and class E. By the way, I must tell you, class D is used for multicasting, and class E is used for multicasting, and class E is used for research purpose, right? So we have 5 classes. We divide IPv4 address into 5 classes, right? Class A, class B, class C, class D, and class E. Class D is used for multicasting and class E is used for research purpose. So we are not going to discuss about these 2 classes. We need to learn these 3 classes, class A, class B, class C only. So guys, let's begin from class A. First of all, let me give you some example of IP addresses. Like here I have one IP address, let's say 10.1.1.1. So if you need to identify that this IP address belongs to which class, how you will identify? You will not check value in these three octet. As I told you, we divide IPv4 address with the help of value present in first octet only. So what is the value in first octet? This is first octet, first field, and value in first octet is 10. So 10 is in this range. That means this is IP address belongs to class A, right? This is IP address belongs to class A. And in second octet, third octet, and fourth octet, value can be anything. Here 255.255.255.255. It can be this also, or it can be 0.0.0.1 also, right? Value can be anything in second octet, third octet, and fourth octet. But value present in first octet will define the class of IPv4. So here in the second octet, value can be from 0.0.02, let's say 10.255.255.255, right? So in this is lowest IP address again, and this is largest IP address from class A. From this, you need to check this value only. Here value is 10, here value can be 9, here value can be 11, anything from this range 0 to 127. That means that IP address belongs to class A. Again, I am going to write one IP address, let's say 172.16.1.1. So this IP address belongs to which class? Again, we need to check first octet value. First octet value is 172. 172 belongs to this range. That means this is a IP address of class B. This is the IP address of class B. In the same way, here I am writing one again mode IP address 192.168.1.1. This IP address belongs to which class? Again, we need to check only first octet value. First octet value is 192. That means this IP address belongs to class C. Okay, in the same way, let me write one IP address of class D also. Let's say 225.1.1.1. C. This value belongs to this range. So this is class D IP address. And let's say if here I am changing the value to 241, let's say 241, so this IP address belongs to class D. Fine. Hope now it is clear to you, and you can identify which IP addresses belongs to which class. Like 1.1.1.1, this IP address belongs to class A. 255.255.255.255, this IP address belongs to class E. 0.0.0.0, this IP address belongs to 0.0.0.0, this IP address belongs to class A, right? 15.15.15.1, this IP address again belongs to class A. So to identify the classes, we need to check only first octet value. What is the value present in first octet? Okay, now how we get this range? How we get this range? So guys, to understand the range, first let me discuss something more about it. Then we will discuss about the range also, that how we get this range for each classes. Before that, let me write one IP here, 10.10.10.10. This is one valid IP address, and each IP address is combination of two things: network bits and host bit. Network bits and host bits. And we have one tool which can identify how many network bits are there and how many host bits are there in a particular IP address. That tool is called subnet mask. That tool is called subnet mask. So subnet mask is a tool which is going to define how many network bits are there and how many host bits are there in a particular IP address. And we have again predefined subnet mask for each classes. So we are not going to understand these two classes. So let me remove these two classes from here. Now see, we have a predefined subnet mask for each classes. Let me tell you the subnet mask for each classes also. Subnet mask for class A is subnet mask for class A is subnet mask for class A is 255. For class A, subnet mask is 255.0.0.0, right? For class B, subnet mask is 255.255.0.0, and for class C, predefined subnet mask is 255.255.255.0. right? Now guys, see, for class A, how many network bits are there? See how many one are there, how many on bits are there, and how many off bits are there in this subnet mask. If you will convert this subnet mask into binary, if you will convert this subnet mask into binary, so binary of this subnet mask is, in the first octet you can see again value is 255. That means in binary all bits is 1, 4, 5, 6, 7, 8, and in the second octet value is 0. That means all bits are 0, 4, 5, 6, 7, 8. In third octet also value is 0. That means all bits are 0, right? And in fourth octet also all bits are 0. Done. This is the binary of this subnet mask. So in this subnet mask, how many 1 are there and how many zeros are there, right? How many ones are there and how many zeros are there? There are 8 ones and 24 zeros. So 1 represent network bits and 0 represent host bit. Let me write here. 1 means network bit, and 0 means host bit. Okay, so in class A there are total 8 network bits and 24 host bit. In the same way, if you will convert this subnet mask of class B into binary, you will get this value here. Let me copy it, and again this value, and then 0, 0. In the third octet, in the third field all bits are 0, and in the fourth octet all bits are 0. This is the binary of this subnet mask, class B subnet mask. So in class B, how many network bits are there? 16 network bits are there. And how many host bits are there? 16 host bits are there. In the same way, for class C, if I will convert this subnet mask in binary, so my binary will be this one. Copy, paste. Second octet all bits are 1, third octet all bits are 1, and in fourth octet all bits are 0. In third octet all bits are 0. This is subnet mask of binary of this subnet mask, class C subnet mask. So in class C, how many network bits are there? 24 network bits are there. And how many host bits are there? 8 host bits are there, right? So now what we can say, for class A, how many network bits are there? How many n are there? N equals 8. And how many host bits are there? H equals 24. For class B, we can say, we have 16 network bits, and 16 host bit. For class C, in the same way we can say we have 24 network bits, and equals 24, and host equals 8, right? So sometime you will see in the book notation is like this also. Here notation is n dot h dot h dot h, means 8 first octet all bits are network, and in the last 3 octet all bits are host. Here you will see representation is like this: n dot h dot h, means in first octet all bits are network bits, in second octet all bits are network bits, and in third and fourth octet all bits are host bit. And for class C, you will see this representation: n dot h, right? So now it is very clear, it should be very clear to you that how many network bits we have for class A, for class B and class C, and how many host bits we have for class A, class B and class C. Okay, so you can take one screenshot of it if you want, if you have a problem in this. to understand, let's say if you have not understood how we have 8 network bits in class A, so you can directly remember it also, that for class A we have 8 network bits and 24 host bit. Now guys, see, out of 8 network bits in class A, we reserve 1 bits. We reserve 1 bit to just to get the range. I need a 1 range for each classes. As I told you, we divide IPv4 address into classes to reduce the to reduce the shortage of IPv4 address. You know, in upcoming day you will understand how we reduce the shortage of IPv4 address by dividing it into classes. So if you divide it into classes, that means you are saving the IPv4 addressing. You will understand this also in upcoming time. For now, try to understand how we get this range. Right, to get the range, what we did, for class A we reserve 1 bit. For class A we reserve 1 bit. We have how many network bits? 8 network bits. Out of 8 network bits, I have reserved 1 bits. That first bit will be always 0. I have set that this bits will be always 0. First bit is not going to become 1. This bits will be always 0. Now how many rest bits we have for class A? For class A we have rest 7 bits. For the network, we have 7 bits. You know, by default we have 8 network bits for class A. Out of 8 network bits, we have reserved first bit. That first bit will be always 0 to get the range. And rest 7 bits can be anything. And if rest 7 bits are 0, let's say 3, 4, 5, 6, 7. If rest 7 bits are 0, that means what decimal value you will get? 0. Because if you will convert the entire things into decimal, you will get 0. And if I will set all rest bits to 1, let's say this is my 1, 1, 2, 4, 5, 6, 7. If all bits are 1, then what decimal value I will get? 2, 4, 6 and one more 1, 7. So you will get this decimal value 127. 127, and this is how we get range for class A. For class A, this is how we get range. Now, you know, if I am writing one IP address here from class A, let's say 10.1.1.1. So see, in the first octet value is what? 10. In first octet value is 10. If you will convert 10 into binary, so binary of 10 is 000001010. This is binary of 10. You can see first octet means first bit is 0, and after that next 7 bits can be anything. So if next 7 bits are 0, then we will get decimal value 0. If all next 7 bits are 1, then we will get decimal value 127. So this is how we divide IPv4 address into classes and we get range. In the same way, for class B we reserve 2 bit. For class B we reserve 2 bit. That first bit will be always, let me tell you, first bit will be always 1 and second bit will be always 0. Now how many free bits are there for class B? See, we have 16 bits for class B. Out of 16 bits we have reserved 2 bits. That means 14 rest bits are there. 14 rest bits are there. We are not going to talk about second octet. Let's talk about first octet, because we divide IP address into classes on the basis of value present in first octet. So in the first octet we have how many rest bits? 6 bits. So if I will set all 6 bits to 0, I will get minimum value. And if I will set all 6 bits to 1, I will get maximum value, right? So here if you will convert this value into decimal, you will get 128. And if you will convert, you know, if you have problem in binary to decimal, guys, you can let me know, right? That you have problem in binary and decimal, I will make one video on binary to decimal also, right? But if you know the binary to decimal convergence, you can easily convert this binary, means 1 0 0 0 0 0 0 is 128 in decimal, and if all bits are 1, then you will get decimal value 191. You will get this value 191. Now if I am writing any IP address from class B, let's say 172.16.1.0, and again if you will convert this value into binary, 172 into binary, you will see first bit, maybe first bit will be always what, 1. First bit will be always 1, and second bit will be always 0, and after that the last 6 bits can be anything, can be from 0.00000 to 11111, like this. Okay, so we have reserved 2 bits for class B to get the range. In the same way, for class C, we have again reserved 3 bits. We have reserved 3 bits for class C. See, first bit will be always 1. For class C, first bit will be always 1, second bit will be also 1, and third bit will be always 0. So how many free bits we have? See, we have total 24 network bits in class C. So I'm talking about first octet only. So we have 8 bits in first octet. Out of 8 bits, we have reserved 3 bits. So we have 5 free bits. So if all 5 bits are 0, 0, all 5 bits are 0, then you will get minimum value, and if you will convert this into binary, into decimal, you will get this value 192. And if I will turn on, set all bits to 1, I will get maximum value 245. I will get maximum value, that is 223. If you will convert this binary into decimal, you will get this value, right? So this is how we divide, we get range for each classes. Got it? Now if I am writing one IP address from class C, let's say 192.168.1.1. So if you will convert this IP address into binary, you will see in first octet, first bit will be 1, second bit will be 1, third bit will be 0, and then value can be anything. Then value can be anything, right? So this is how we divide IPv4 address into classes. Now question is, how many network we can design from class A? Sometime interview is asking this question also. So formula to calculate number of network is very simple, 2 power n. 2 power n, number of network. Formula to find number of network is 2 power n. 2 power n, where n is network bits. Network bit, where n is network bit. Let me write here. Okay, done. Now from class A, how many network we can design? See, we have total 8 bits for class A, 8 network bits for class A. That means we can design 2 to the power 8 network, but we have reserved 1 bit. So because we have reserved 1 bit, we can design 2 power 7 network. 2 power 7 network from class A, right? This is exam question of ccna 200301. For class B, how many network we can design? See, for class B, we can design 2 power. How many network bit we have? For class B, 16. But out of 16, we have reserved 2 bits. So we can design 2 power 14 networks, right, for class B. And for class C, how many network we can design? We can design 2 power, not 24, 21, because total number of network bits for class C is definitely 21, but we have reserved 3 bits. So 2 to the power 21 network we can design from class B, class C. So this is basic things about IPv4 addressing. Hope it is clear to you. Now if you have any doubt, please let me know. Otherwise we will discuss, there are many more concepts about IPv4 addressing and subnetting, but we'll discuss in next class, because I want to make a small videos on IPv4 addressing, because it is important. Now if you have any question, any query, you can let me know in the comment section. Okay, that's all for today. If you like something, if you learn something from this video, guys, please hit on like button. That's all for today. We'll meet soon in next video. Till then, stay safe. Bye bye. Thanks for watching.